One. Boom. All right. We should be live. Very nice. See a lot of friends there throwing comments in the chat. It's great to see you guys are hanging out with us for a little while this afternoon. We're gonna dig into some cool new features and functions under the turning side. Now, I will say some of these will be maybe optimized for our control, but not necessarily a requirement to have a SINUMERIK control. So we won't hold it against you if you don't have one yet, but we do expect you to get one really soon. So with that said, I just wanted to take a few moments before I introduce you to our guest presenter to kind of introduce you to my team. I do have the pleasure of leading a great group of guys. We call it the Technology Application Team. Within that team, it's myself, Brian Baumgartner. We are both based in New York. Brian's upstate in God's country, as we like to say, and I'm downstate by all the riffraff, but that's okay. Out in Illinois, I have Adam Caves as well as Dan Struble. So if you guys haven't met us yet, I look forward to getting a chance to meet you at, I don't know, next trade show, open house, customer visit, who knows? There's all kinds of stuff going on. So from that side, if you guys aren't aware of what we do, we kind of drive all things kind of operation and programming based. We certainly are driving the SINUMERIK technology in the market space, and we do develop a ton of classes. So if you're looking to learn more on the SINUMERIK control, or maybe just expand your knowledge of CNC programming in general, I would say go to our main website, which is that CNC View website. You see the email address right there on the top of your screen. From there, you can go to CNC Training. All of our classes are 100% complimentary. We do have a couple different flavors. You can attend them online. Everything's instructor-led. Through these, more formal training classes. On the advanced technology, we also offer some of this stuff in person at our Illinois facility. So that would certainly be well worth your time checking out. If you don't know, hopefully most of you do, we also have our own YouTube channel called Mr. CNC. And there we have a ton of self-paced content. So there's all kinds of videos up there. I think to date we're somewhere 170 plus videos. This webinar will get posted there for sure, the recording from this, as well as we do a lot of like smaller how-to videos and stuff. So if you don't know the channel, check it out. Absolutely like and subscribe. I'll do my little YouTube thing, but there's a lot of content material up there if you're just trying to get into SINUMERIK, maybe just expand your knowledge of just machining in general. There's all kinds of stuff for just about anybody there that's in our industry. And we do also have a great program we call our Machine Tool Product Expert through the VPE program, which is a Virtual Product Expert program. And the VPE program allows you to get access directly to a product specialist. So what you do is you go to CNC Review, you go to the Virtual Product Expert link right there off the main page. You can fill out a little, just a quick little questionnaire of topics that you're interested in. You'll get reached out by Brian Baumgartner, one of the gentlemen that works for me, and we'll set up a live, live web-based session to kind of dig into those topics. So it's a great way to get access to a product specialist that you may not know who to call. Let's face it, Siemens is a big company. So with that, we're trying to make navigating it a little bit easier for you. We also have our content manager, great way to kind of get access to some of the key material that that we offer out there. All of the links to all of our videos, whatnot, that is available on CNC for you. You can join our contact list, which I certainly hope you do. Actually, by attending this event, you did opt in for our contact list. So guess what? You're already there. And we have a bunch of additional social media platforms that we're on. But I just wanted to give a quick top level as to kind of who we are as a team, some of the things we do. And now I want to bring in my colleague, Dan Struble. So Dan is going to be joining us here on the event. And I might as well will pop up you and I real quick. Dan, there he is. Look at that smiling face. I
Thanks for
love
having
your
me.
I love your industrial looking background. That thing almost looks real. That's pretty cool.
I know it is, actually. It is real.
Mine's real.
Thanks.
I can touch mine.
Yeah. Well, I didn't pay for this background.
You sure about that? Anyway, so Dan works for me. He is one of the CNC product specialists. Certainly a wealth of knowledge. So Dan, thanks for joining us for sure. You're going to be kind of leading us through this topic of advanced turning technology. So I kind of give it over to you. So at this point, why don't we give you control? All right,
Thanks.
you have it. And yeah, I'll be here to support you.
Yeah, so we're going to talk a little bit about turning today. So a couple months ago, we had a webinar where we went over the new things for SINUMERIK for milling. This is new things for SINUMERIK 1 and 828 for turning. So some of the new things to come that kind of give us an advanced look at what we can do as far as turning goes. So we're going to go through a couple different topics. So the first one is we're going to go through comb grooving. What is comb grooving and how do we utilize it and why to utilize it? So the first one, we have this cycle that we call comb grooving or grooving cycle. And then inside the grooving cycle, we have an option for comb grooving. We didn't have that before, and now we do. And the reason why this is so effective, and we'll actually see the demonstration of this, is this actually can save you up to, in some cases, up to 100%, depending on how your groove is. It definitely gives you a way quicker way of roughing out a groove on a turning machine. So let's take a look at that. So if we go to our lathe here, we actually can go inside the program and kind of show you how easy this is to set up, right? So this is an option, and we have our groove cycle here. Normal to what we would have before, but now we just have an option for comb grooving, right? So we have alternate, which is the way that you would always use our cycles for grooving. Now we have comb groove, right? And we can do both, and I'll show you the example. So if we execute this, you actually see why it's called comb grooving and why it actually gives you a much more increased cycle time. So we got our groove tool come out. We're going to orient and actually start to groove here, right? And so why it's called that is it, when we see our shape here, it's actually going to look like a comb. And the nice thing is we're taking full width of cut, and we're not alternating back and forth. And because of that, we're staying in cut longer. And now we're just going to go by and break down all our individual comb pieces that we've created here. And if we looked at the cycle time, just in this cycle time, we're a minute for this cycle time. If we use the alternate, we're like a minute 20. So if you had you know, not this virtual type of material that you could cut, if it was steel or something like that, you might be 5 minutes for alternate, and you might knocked it down to 4 minutes. So having this capability to really rough out a groove really helps out. So if we just went back now and switch this, we can really switch it back to alternate, and we can now run it, and you can see the difference, right? So the difference is we're going to come down and we're going to basically alternate out the material here. And I can reset the material, we can see it, but as you can see, we're jumping along versus just doing each individual strand and then coming back and cleaning it up. And if we look at the time count here, we're going to be just a little bit over a minute cycle time for this groove, when before we were under a minute. So if you extrapolate that out for some grooving, you're definitely going to be able to save some time here. So I think we're like a minute 20 with the alternate. So just in this one, we're saving quite a lot of time here. So minute 18. So we're definitely being able to save some time with this operation. So we're going to move into the next topic. I think we have any questions in the chat or anything on this.
I get a question.
Go ahead.
So, what if I don't have a SINUMERIK control? Can I still do comb grooving?
Yeah, you can do this as long as you have a cam or some way of supporting this. We have a cycle that's on our control, so this is making it quite easy to do, but certainly doesn't necessarily have to have a cinemeric.
Now, I don't know about you, but I don't think I've seen a cam system yet supporting this cycle, though. Have you ever seen one?
No, so you would have to write this by hand.
Yeah, that's what I think so. But it's kind of a cool concept if you think about it. I get the play on the kind of the pun on the term comb. It does look like a comb, but having played around with it firsthand, the fact that we can kind of stabilize that tool and do a full width of cut for all that volume of material removal does seem pretty cool.
Oh
Neat.
yeah, yeah.
So from there, I was looking at your little punch list. It sounds like we're going to dig into some new tools. I'm assuming this is probably going to be a little more Cinemark specific, right?
Correct. Yeah. This is something that's been coming and been wanting, I think, for me and you for a long time. That it's been a huge ask. So, yeah, we're going to get into new tool types, right? And so, why has this been a big ask for us? It's because one of the things is when you go to a B-axis machine, you have this head that actually is doing the turning, but then you can actually tilt the head. And the reason why is if we look at this as we bring one of these tools up, we want to have that head be away from the turret and I'm sorry, the wall and the chuck. So having it on a 45 degrees really gives you the capability of, you know, not colliding with anything. So tooling manufacturers have developed some nice tools that give you a capability of having 45 degrees, right? And so even with threading tools and with grooving tools and cutoff tools, now we can get really close to the chuck and not have to collide. Case in point, if we took this groove and we moved it, if we move this groove closer to the chuck, oops, sorry. Let's see, I was saying at minus 20. Let's see if I go, I'm doing this off the cuff. So if I go minus 50, you can see if we were straight up and down, the type of tool that we would need to get and how long we would have to be if we were doing it. If we had to go straight up and down on a groove, this head would be getting really close to the chuck. And that's really the benefit of having these tools. Now, what was something that we didn't do before is we didn't have a way of describing these tools. So now on our tool page, we actually have this where we go and make a new tool. When we go into turning tools, we actually have a plunge cutter incline. We have a cutoff tool incline, right? We have a Y cutoff uh, tool. So we have these new tools. So we have plunge cutter incline, cutter incline, and then we have a threading incline too as well. So three new tool types that really, really, really give you a benefit. And as you can see, having that head at 45 degrees gives you the capability of getting really close with your tool and not getting the head and everything close to it. So this is something that me and Chris have, we've had customers like, how do you describe a 45 degree threading? And you're like, what do you mean? Well, a 45 degree tool that has a threading insert in it so that you can utilize this and get that capability of having that clearance on a B-axis machine.
I can absolutely attest to that. The amount of customers I have asking for that kind of tooling has been forever. But what's now the big benefit of having that tool type there, right? I mean, obviously, I could have previously driven the B to 45.
Yeah, the benefit is the insert is being described and what we're using it for, the width of it, so then you can utilize these tools in our cycles and not have to, just say putting our head at 45 degrees. So now we have a way of controlling that and using it inside our cycles and making the life a lot easier. So if we wanted to do shot mill, we could totally do shot mill with it. If we wanted to use program guide, we can totally use that. We can use our cycles utilizing these tools.
And that's the money shot right there, right? That was what we couldn't do before. We could, yeah, support the tool for quite some time, but I'd have to run out the cam system or program it
Yeah.
longhand. So to be able to use the can cycles for stuff like that, hugely important. And I know from experience, like you were talking about holding that B vertical, but the other case scenario is what if I'm fully sending the B horizontal, right? Or I'm sending the B at B0. Now I got to worry about the sub spindle and all that. I mean,
Oh
some
yeah.
of these spindles get pretty long. No, very cool. All right. So there's been something I keep hearing a lot about, and it's certainly new to me. It seems like it's a big buzz. I'm kind of questioning: is there really any validity in the product, which is y-axis turning? Right? Is this just the new gimmick that's out there, or is there some real meat behind this y-axis turning? So I saw you had it on the list. I'm super excited. We're going to kind of dig into it.
Yeah, so the next thing on our list is y-axis turning. Just to kind of lead in, we got some pictures here. And what is all these pictures and what does it mean for our control and how do we utilize it? So, there's always been this kind of buzz and it's been kind of going around because the first to come out was like y-axis cutoff. That definitely has they've been a lot of tooling manufacturers running around and saying that. But the new one I think is going to be definitely huge that you're going to hear a lot about is you're going to hear y-axis turning a lot, because if you think about it, when we start to go through this, there's a lot that kind of goes into play about forces and chip control and things that just don't really you talk about in lathe world, but are huge when it comes to how you're doing it. And then, which as a beginner in lathe world, the thing that I think when I remember back and not knowing what I didn't know about turning was I did not know what the difference between a right-handed tool and a left-handed tool is, and the benefit of it is, and all these stuff. So to put that into one tool, I think is really huge, and you're going to see the benefit of this. And I'm going to demonstrate it, very, very quickly, because I think this topic, I think really warrants its own dedicated webinar and YouTube live, maybe, where we're actually on a machine cutting. But for the sake of this webinar, I definitely want to just kind of take you through some of the basics of why I think this is cool. So one, it's definitely helping the forces of turning when you're turning on a B-axis machine, and it's helping, chip control. And then the biggest thing in my opinion is just so much versatility between left-handed, right-handed. You can take bigger cuts with this. So there's a lot that I think that we can do as this technology evolves. I think it's going to even get even crazier, because then you can do free form surfaces in the future. So I think this thing is going to be definitely huge when we start to see this in the turning world. Unfortunately, right now, this is really kind of exclusive to B-axis turning. So this is the same as the incline tools. This is really kind of focused on B-axis turning. This is where I think you'll see the biggest bang for your buck. But as I show this, it is really interesting. So let's just kind of get into this. So what I'm going to do is I'm going to zoom out. I'm going to refresh my material so that you guys can see this. And I'm going to try to get, oh, I'm in a program. That's why. The spindle was spinning. So I'm going to go to MDI, and I just have the tool kind of prepped and positioned here, right? So she's going to go away and she's going to put the y-axis tool in there. And we have cycles prepared for this, but as we can see, we're positioned on the y-axis, right? And we're in the 0 position. So this is just, we're controlling this with edge numbers. So this is D1, right? But in D1, I can change this angle and use whatever side of the insert that I want. And if I go to D2, now I'm going to use the other side of that. And I can change the angle. I can either use this side of the tool or this side of the tool. I can use whatever side I want. And then D3 is the other edge. So each one of these, I can use each one of those edges. But if I go into each one of these cycles, I also can change the direction of that. So the first one was 0. Maybe I want 10 degrees, right? And I say accept to that, and I run it one more time, right? Now I have a 10 degree, and I could cut on that 10 degree. This whole edge I could use to cut on. So this is where I just think this is super powerful, right? And let's say I go back to that and I want, I'm cutting this direction, but I want to come back the other direction. I could totally change that too. So this is where I can go, -10 now, right? So this is super, 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 I think, powerful. Now I'm pointing in the, maybe a right-handed tool now. So I'm coming in there. So really, really powerful on the versatility of what edge I'm going to use for per insert, right? But then if we think about this from a cutting perspective.
Well, hold on. I think there's one thing that I just want to make sure everybody caught, which is really actually pretty cool. Did you watch how the system is tracking that zero location? So as you change from a positive to a -10 degrees, the machine actually moved forward because it's maintaining that point. So that's really where this becomes kind of game changer. Well, when letting the control kind of handle all this, right? We're allowing you to adapt that zero location to any orientation of that tool.
Yeah, it's interesting. Let's do that one more time so you can see it, because I agree, because we're pointing at this direction and all I'm doing is changing. I'm running the same program. I'm just changing the edge. So once I change the edge again, right? So I go 1, I'm on D1, right? I go 2, I'm on the second edge, and it's going to go to that point. It's going to the same exact point because it knows that that's the edge that we want. And as I change again, it's going to rotate and change and make sure that point stays constant. So it's always tracking that point, which is super, super huge and making life a lot easier for you. And then talking about cutting forces, right? If we look at this, if this is as this is spinning, we're actually spinning and the forces are going up, right? Versus if we were on a turning tool, we're kind of the turning tool is kind of the forces are going this way. So this is going right up into the most rigid portion of the machine, because now this is sitting like this. It's being held between this machine is being held right here, right? So this is all the forces are going this way. So this is, I think, going to really showcase more heavier cuts as well as being more stable.
Yeah, and I mean,
So
we were playing around with it just recently when we had Claudio here, and I mean, it could be double the chip load. It's
yeah,
unbelievable. But to your
yeah,
point, it's a force thing, right? We're directing the forces directly up into the spindle bearings, right? So we have an axial load as opposed to a radial load. And I
yeah.
mean, anybody knows anything about a spindle bearing, you can drill a lot more aggressively than you could mill, right?
hmm Absolutely.
No, very cool.
So we can kind of see this now as we look at the traversing x-axis versus the y, right? It's coming into the tool versus towards the tool in the most kind of towards the holder versus up through the holder. I think this is where we're going to be seeing productivity 3 times faster in cutoff, and then we might even see 3 times faster in chip removal too. So I think it's really going to show kind of productivity. So I think that's huge. So with that, right, we come to a whole nother thing of new tools as well. So we got roughers, we have finishers, we have Y-ax plunge cutters, we got Y-ax cutoff tools. When you describe these tools in our system, you have the ability to use them with our cycle. So we have stock removal, groove, undercut, cutoff, and contour turning. So all these can be used in our cycle, which again is huge, right? And then, all really when we go to our cycle, we're basically just saying, we're going to use Y cutoff either in a grooving or in a contour. We have this new button that says Y-axis turning, and then it knows that we're going to be using stock removal or contour or grooving. So I'm going to show you that back on the control. So as we go to our program here, we go to our program here and we kind of go through it. If we come here, we have this new Y-axis turning, right? And so in there, we have stock removal, groove, undercut, cut off, and then we have the selection of our Y-axis cutter. So here, when we go into that, each one of these screens, we select that we're going to be doing Y-axis cutting, and then the direction of our insert, and then a start position, right? And then right into that, I made a contour, and I'm going to call that contour, and then I'm going to basically do some cutting. So as we move through this, that's just basically how he is. I'm calling the y-axis tool. I'm going to use the same cycles that I would before, but now I'm just going to use it in y-axis turning. So as we do this now, as you can see, I'm going to try to stop this right here. So now if we look at this, I'm using edge 3 and I'm going to come down like I would an 80-degree tool, and I'm just going to face this front part of it. So that's pretty much what we're seeing here. This would be like a traditional 80-degree, and I'm going to face this first part of it. Boom, done, right? And then I'm going to now reposition, and I'm going to change my insert. Now I'm changing now to like 10 degrees, and now I can take a really heavy cut on that long side of that insert and really do some stock removal, right? Boom, big pass. Another big pass. So I can really start to get material out of my part relatively really quickly. So I think this is where it's going to be really huge. And then again, I have some contour here, and this is kind of like, you know, your left-handed tool. I mean, I'm sorry. Yeah. Left-handed. Yeah. So we kind of have a left-handed. We now we got to change direction so that I can actually finish this, right? So now I was at like a right-handed tool. Now I'm at like a left-handed. So now I can go in and clean out the areas I couldn't get.
I mean, how
And I
cool is that, right? Just to talk about like utter versatility on one
super
tool
versatile.
behaving like a half dozen tools.
You know, and then
Now,
in turning, go ahead,
I do have a
please.
question for you. I'm sorry you were in the middle of speaking, but so obviously what we're showcasing here is on B-axis technology. Is there any benefit to Y-axis turning on a turret style machine?
I think there would be some benefit. I think a lot of benefit would be in the y-axis cutoff.
Yeah.
I think that is, I think, huge on just like a traditional 2-axis or 3-axis turning, because you definitely can see that benefit there. So that's definitely going to be huge. If the world of this type of using y-axis turning, I think it's still going to wait and see if there's going to be turret-based tools that if you have enough swing in the y-axis for a lathe, you know, because some lathes have y-axis. I think could warrant some of this, and I think it could be huge because again, your force is going towards the turret, right, through the turret, right. So until that, the only thing there is you wouldn't get the benefit of having the versatility of one insert being left and right because it's going to be fixed, you know?
Yeah, unless they drove it through a live tool holder, but those are notoriously kind of weak.
Yeah.
I think that would be challenging. Yeah.
So let's go back to the presentation. I think we're moving on to another topic here.
Oh, prime turning. Yeah, this is a good one. And actually, there were a few questions in the pre Q&A on this. So educate us. What is prime turning? Why would I want to use it? Do I really want to use it? Is it worth the gimmick?
Yeah, so prime turning is definitely going down to a 2-axis or 3-axis lathe. You don't need a B-axis for it, even though I see capital here. And I would challenge people, if you're on the call and you do have a lathe, that if you don't have capto for your 2-axis lathe or some style of quick change for your turret, I would 100% challenge you to go down this path. There's a lot of options out there. Capto is one of them, and the reason being is you can quick change these out. So the reason why I'm showing this is twofold. I wanted to show you and explain prime turning, but I also want you to make sure that you're taking advantage of your lathe completely if you have a 2-axis lathe, that you can use these same tools. They're not just for B-axis. They're also for 2-axis lathes. You can get a Capto quick change holder where you actually can quick change these out. But moving on to prime turning, what prime turning is similar to kind of y-axis. You're utilizing some of these longer parts of the insert to do some roughing, and it's also again taping in some versatility. So not only can you use this long part of the insert, right, you also can use the front part of the insert like a traditional insert. So not only can you rough and pull with the insert, but you also can come back and use the front part of the insert to finish or to kind of get into soup places. So again, become creating a lot of versatility with the insert is really huge. Now I started out when this first became out to the market and did a lot of testing when this was coming out, and this is really proprietary to Sandvik. These are Sandvik inserts and Sandvik holders. And really, as an application engineer, being on a lot of projects, this really prones well to a lot of gummy materials. So your stainless steels are, I think, are really huge because you're able to use a bigger part of the insert to create a lot of chips. And from those chips, you really can move a lot of materials. When you're using these types of exotic materials, you're able to pull from it. So kind of how it works is, oh, let's go back, is when we have conventional style of turning, we're usually pushing and going towards the chuck. What PrimeTurning's idea is you're using that long part of that insert and you're going away from the chuck. So you're actually pulling away, and this you're being able to go a little bit faster. So a little bit cost effective because you're going to be able to go faster, 50% reduction in cycle time. We have the ability of having the same amount of edges that you would, and you are able to go a lot faster. Now, the trick with this is, and the hard thing that this has not like been the how does everyone not have a prime tool is this requires a, either a cam system that knows prime turning or having some capability of doing this on the control, because at the end of the day, most cam systems and most cycles on controls from a conversational standpoint, they are to the traditional. They want to go and push towards the chuck. They don't have pulling back. And one of the big things about this is that's not handled well in any cycle, because why would you do it, is you have to arc in. You have to arc into that, and doing so you have to you have to do that. If you don't do that, you can have catastrophic failure. So definitely there. So I can show you each one of these tools. We're going to reset our workpiece here, right? And we're going to bring out both tools, right? Kind of get oriented here.
An interesting machine. The spindle's
Yeah.
floating.
Yeah. So I'm going to go to my prime tool demo here and reset, execute, start. So the first one I'm gonna pull out is this is what the two different types. This is the A type. So we have the star style. So we can either use this side of the insert or that side of the insert. So definitely a lot of capability there, right?
So what am
Then
I
the
what am
next,
I getting? Three cutting edges out of that tool?
yeah, effectively
Not double
one,
cut, right?
yeah, one, two, oh yeah, three cutting edges, yeah,
Yeah. Okay.
yeah,
Yeah, I mean, I get it. You're back turning with it. You can actually turn in both directions with that
yep,
tool, right?
yep. And then this is the B style, right? Oh, sorry. Was hitting cycle start. So this is the B style. So we can, turn with the back side and then finish with the front. And that's kind of what we're doing here too. So as you can see, I'm going to utilize the cycle and start turning with it, right? So as you can see, we arc in and pull the material away from the chuck, but always an arc in and pull away. And this is the whole point of this tool. And then as I'm starting to do this, I can start to utilize that and then come back the other direction and finish it. So again, the premise here, you're saving on tool changes, right? So there I just did that for an orientation change, but we could have definitely oriented right there. But as you can see, I pulled and roughed in one direction, and then I came back and finished the other like a traditional insert.
So I am curious. Like, I know they always say you got to do the arc in, but what do you think is unique about this insert and the insert geometry that really requires us to do the arcing? Any idea? I mean, I know I'm putting you on the spot here, and you're not a cutting tool guy, but I am curious.
Well, I don't know specifically why the what has to do with the insert. I can just tell you from felt experience, if you don't arc in, it is catastrophic failure.
Yeah, that sounds like it's coming from firsthand knowledge.
Yes. Because we learned about this because we're like, oh, I was like, oh, we got to pull it backwards. I've been around CNCs. I don't need no cam system or no cycle to tell me what to do. So I just literally programmed it and did it the first one where I just came in and I can show you I can show you here when we get the other tool is I just was like, okay, well, I got this tool. They say I got to go away from the chuck. I came and put it in there like this. And I just did a straight line backwards. And yeah, she just took the insert right out. So I'm
I
not
mean,
sure.
it must have something to do with the infeed, right? Because when you're back
Yeah.
turning, it is going to plunge straight in
Yes.
to chip depth. So I guess for whatever reason, that insert will not plunge like a traditional, ISO style insert geometry.
And I'm assuming probably because you have two contact points, because if you're coming in there, you're plunging straight down.
Mm.
As you're arcing in, you're getting more of the material. I'm not quite sure of the reason why, but I will say firsthand knowledge, yeah.
And
Even
do you think
every time,
that stands true for both inserts?
I believe so. I more
I mean, I
more of the
know
stuff.
we do from the cycle side, but I wasn't
Yeah,
sure.
yeah.
All right, cool.
Yep. So, here we have our we're with this option on our control, we have both tool types being described, right? And then just like we were with the comb grooving, right, and y-axis, when we go into our cycles, we are able to now use it in contour and stock removal. So when we go into our cycle, we have that option for prime turning now. So we can have prime rough and we can have prime finish. We can choose the direction here in our screen. So this is definitely here. So this is nice. So you can program right on our screen. Before, you'd have to have your cam system would have to have the prime turning operation. This now has it right on the control, which is just making life easier for you. So I think we're going to the next topic.
Oh, interpolation turning. So this one has always held a close portion of my heart. For any of you that have been around our YouTube channel for some time, back in the day, I did do a series of videos on interpolation turning. Actually, on my little machine behind me here. If I was to show you back, believe it or not, I've interpolated the interpolation turned even on that machine. But this is kind of cool. So back in the day, we used to either have to do it longhand or we had an air quote it unofficial cycle that you could use, but it was absolutely unofficial. I mean, it would run a metric. It wouldn't even run an inch. So this is the new one, right? This is the
Yeah,
new native strategy.
yeah, yeah. So this is native our control, and it's using our cycles that are inside this. And again, we have a button now for interpolation turning, so we have that capability to kind of walk through this. So if you need to take a turning tool and use a contour, you can totally do that. So one of the things it does is it actually uses its own interpolation turning transformation. So that would be one of the things that would be needed to be on your machine. But in that case, it is once that's implemented and installed correctly, now we have actual how we're going to use it. So, just like the y-axis or, utilizing that, it has its own screen to showcase what you're doing for what, are we starting internal or external and how our insert's pointing. And then right from there, we're able to utilize our are the cycles inside interpolation turning. So you want to do a bore, you want to do a face, you want to do a contour down a body, you could totally do that too as well. So we go back to the machine now and we open up just kind of a program and we say new, right? And we see this interpolation turning. So we have a set. So this is actually going to be selecting, right, where our insert is, and what we're facing, and then the direction of our spindle. And then right in here, we can do stock removal. So we can do stock removal, just do a shaft. We can do a groove, right? We can do a groove. So we're going to do a groove. We can even do a contour turn, right? We can do a contour with interpolation turning. So why would this be beneficial? On a lathe, a couple things come to mind. One of them might be just like you're trying to do an O-groove turn that you don't want to have to spin it, or you have an O-groove turn on a 40 O-ring turn or O-ring groove on a 45 that has a really big call out that you can't turn. So this way you could totally do it with interpolation turning. So that's pretty much the bulk of what's new with turning for SINUMERIK and SINUMERIK 1. I think we have some time for some questions. If not, Chris, do you have some questions?
I always have questions, but yeah, no, we do. And for those that maybe haven't plugged anything in yet, go to the questions tab if you don't mind, and start plugging your questions in there. We do have a few questions sprinkled through a very active audience chat panel. So bear with me here while I kind of go through. Doo -doo. So I think Bruce was asking what software version. Um, that could be which one we're using here for the demonstration, which is 625, as you see in the upper left-hand corner. But as the features were presented, we did actually have, and if you could jump back to your slide deck, we did actually kind of show you what version of software each of these things kind of came out in. So you see that in that little upper corner. So for comb grooving, it says 6.15 and 4.95. So that's an important note. Not all of these features are immediately available, in maybe older legacy controls. So when you see the 495, yes, we're calling that out specifically for the 828. But if you happen to be a user of an 840 system, which there's a ton out there, 495 is the last parallel version um, of 840D solution line to the SINUMERIK 1, which is, in this case, it was 615. So I would say, yeah, we could go through each of these, but I would say if you're interested in any of this technology, for sure on the SINUMERIK 1 side, it's going to require a minimum of 615. Some of this stuff is 6.2 and newer. Just reach out to us. We'd be happy to kind of give you a little more insight if there's a specific feature you're looking at. Dan's somebody said 624. I'm not sure what that was referring to.
I think I was just responding to what I'm using. I'm using 625 actually, not 624. Sorry, Bruce.
Jesse was saying it's so nice not to have to lie to the machine to get it to work like other controls. We certainly appreciate that. Eric was he was talking about my y-axis tool comments here, reducing motion per tool orientation, certainly angle and load. Brian is asking about the SMTE cycles. So we are going to hold off, and we're not going to get into the new SMTE cycles on this webinar yet, but we are looking to support them or talk about them in the future. So as a teaser for those that are here, we do have a whole series of new cycles that can be added to a control that aren't necessarily native. It's kind of a neat delivery method we're doing. So we will get into that in the near future. If by chance you saw my last webinar, I did promote a little bit of the SMTEs on that. But Dan, we do have some other ones as I dig through here. So what would you say the biggest limitation would be to y-axis turning?
The biggest limitation to y-axis turning is the size of the part.
And
So if
size
we
the part Y. Like, what do you mean
uh
by that?
so if we bring out this and we go to y-axis turning here. So if we look at this, right, our tool holder length in respect to how much y-axis travel we have, right, is going to be the reason why we have a limitation on size of part, because at the end of the day we can only get so long with the tool, and we can only get so far with the y-axis travel. So that's going to be the real limitation of it. So I think to this point, this is one of those big limitations.
So we're going to specifically apply it on smaller diameter parts, we're saying.
Yeah, I mean, within fitting in within the size of the chuck and the y-axis travel, I think is the big thing there. I think as you get to, I would say 10 inches, I think you're losing out on that. And if you're getting that big, I think what you're going to end up seeing is you probably have a different strategy of turning in that case, anyways, if you're that big.
Got it. Another one we have here. So this looks like it's referring to the prime turning. So does this mean we have to use Sandvik's special turning tools?
Yes. So particularly majority of this, you're going to have to use Sandvik tools. However, there are some companies that are coming out with similar type tools that I would think would be needing some of this that I've seen starting to pop up. But as tools are being specified, that is proprietary to Sandvik.
And I'm certainly from our side, the insert geometries we have in there are
Yeah.
Sandvik.
Yeah,
So
they're
if somebody
only
else comes out with one, it's probably going to be a different shape.
Yep.
Yeah, yeah, good point. Um, can the prime turning improve the surface finish of an ID sphere or spherical circle?
I am not sure the answer to that question. I think that might be one to kind of dive a little deeper in with Sandvik. I'm not sure.
Yeah, I don't know. I don't know either. I mean, obviously, constant surface speed in my mind would have a bigger impact, right?
Hmm.
Maintaining chip load. I don't know. Is there maybe more relief, or is it freer cutting than a traditional like VNCK, like a 35-degree insert? I don't know that.
Yeah.
I think that's something that, yeah, I would probably pay to maybe interface directly with the Sandvik rep, because obviously they developed the technology. So I would say certainly, Lena, if we can find any more information, we'll reach out to you. So this is an off-topic question from Tim. So how are speeders accommodated in the control? So I guess he's talking about when he says speeders, maybe spindle multipliers.
Yeah, I think so. Um, I think they're handled, third party externally right now. I don't know if there's been any work to handle it inside SINUMERIK right now. In
I mean, I couldn't say there's a whole lot we would have to do from our end, right?
No.
I mean, I think the only thing that you'd have to consideration outside of, building a tool with the projection, and if we were like using collision avoidance, obviously we could certainly have the geometry of that speeder in there to have a protection element to it. But I think the biggest thing is you have a multiplication factor, right? So if I got, let's say, 1,000 RPM coming into the speeder at my spindle, then depending on what the multiplication is, maybe I have 5,000 or 10,000 coming out the other end. I will say I'm doing an interesting application right now with Fryer Machine Systems and Martin Guitar. They use our controls exclusively, pretty much, for making their high end guitars. And in that case, we're actually tool changing in electric speeders. They're not spindle multipliers because the main spindle doesn't have to spin anymore. But these are 60 1,000 RPM electronically driven spindle speeders, because they're doing these like 10 thou diameter tools on tiny, tiny stuff. And I mean, effectively from that side, we just want to make sure we program the feed rate accordingly. I would say the only thing that an OEM might need to be part of is in that specific application, the main spindle is not spinning, right? So some OEMs don't allow you to do a program feed if the spindle's not spinning. So that's the only thing I think. If you have a machine from an OEM and you're looking to put in like on one of those electronic ones where it doesn't require the spindle to be spinning, just make sure you can do a controlled feed move, a G94, right, feed per minute move with the spindle in M5 or not spinning. That's about the only thing I think would mess you up. Other than that, there's no reason why we shouldn't be able to support them just natively.
Yeah.
All right.
And
Keep going, Dan. Sorry, I'm going to look to see if I missed any.
to that point, Chris, one of the things that's nice about our control is the fact is the spindle, as long as you're using our spindle drive, can be turned into an axis. So you can just dictate 0, and now it's 0. And you can change that. So in that speeder application, you just say S pause equals 0, and now it's 0. So
Right.
that's super huge.
So Jesse was asking, what would be the benefits of interpolation turning over using a boring head? You
The
want to
benefit,
one, or you want me to jump in, or we can both answer it?
we could both answer it. One of the benefits there is the fact is if you can't get to that. So, like for instance, I can show you. I think here. I think this is no new demo.
So while you're pulling that up, certainly some of the things that come to mind, boring head versus interpolation turning. I mean, think about the motion or the tool path and the chip load. It's really the same, right? Very, very similar. One of the things that you'd be somewhat limited unless you had one of those high-end programmable positionable boring heads is how do you do a contour with a boring head, right? That would be a challenge. So a boring head is going to allow you to handle simpler geometry, but once we get to something a little more complex, even tapers like cone shapes, and we can do any contour in interpolation turning. I think that and the ability of obviously supporting any diameter size with that same tool kind of comes into play. Oh, so you're decking a little surface for us to do some interpolation turning. Looks like you didn't have quite enough clearance there. The collision.
No, yeah, because I don't think this is the right part, but I just wanted to kind of showcase.
Fine.
If we had a bore here, that would be pretty hard to do with the boring bar, right? Like if we, we could do it with a boring tool, but now if we had a shape that we wanted to put in there or a contour, in this case, we had a little bit of, we were actually having like a little bellow here. You couldn't do that with a boring bar. You would have to,
Well, boring head. Yeah.
I'm sorry, boring head. And then here, like you said, I think an ID, yeah, I mean, I don't know if I completely agree with doing contour milling, but you couldn't do any type of shape or contour like Chris was saying here. And then a lot of times I think in the applications that I've asked that customers are like, I gotta have interpolation turning. A lot of times it's on this face and then on this face. And like if you needed to have a groove or something for an o-ring or a gasket, if you can imagine the boring head that you would have to change into the spindle in order to do that and to maintain that, you're probably losing pots. This I can just use a groove tool and just groove in my gasket ring or my o-ring right to this. And I think that's really what it comes down to. And then two, a lot of times when we talk about that, we're not really looking at a part like that. We're looking at a huge part like this. So you could never tool change in a boring head to do that type of groove or bore. That's why you're doing a big interpolation turning on a big diameter part or a big hub that has it in a big type of machine.
Yeah, absolutely. I would completely agree with that. The applications Just about every time I've had to do like legit do interpolation turning outside of like a machine like this where we're doing like compound angle interpolation turning, is usually on some big massive horizontal boring mill. And they had some kind of like a boring journal, an ID, and they wanted to be able to blend a chamfer or radius into that bore. They wanted the chip load control as well as the surface finish of a turned surface, so they didn't want to mill it, and it was on a machine that wasn't even a lathe, right? And to try
Mhm.
to have a boring head for a 2 foot diameter bore just wasn't practical. I will say from experience, where the limitations are is the speed of your axes, right? If you can imagine what we're doing, we're moving effectively the X and Y linear axes as they're spinning around in a circle. That's simulating your spindle. So however fast those axes can move are going to be your biggest limiter. So when you're in small features, this is super slow. It is not worth your time.
Yeah.
But when you get to a large feature, you don't need a lot of linear speed out of your axes because you're talking about surface footage at that point, right? I'm out at a 3 foot diameter feature. I don't need that tool running around that really fast. Maybe on a big lathe, I might only be running that thing at 50 RPM or something to get some serious surface footage. So it's like anything else. It's another bullet in your belt, so to speak. But I would say you have more complex geometries that you need to have a turned finish on, or large geometries. I think that's really where it benefits. You want to get a better tolerance, a precision fit, go boring head for
Yeah.
sure. It's going to be much more accurate because now you're relying on the positioning of the machine interpolating for accuracy. But great question. Thanks, Jesse. Appreciate that. Looks like Brian has one. It was mentioned that now one y-axis turning tool can act like a half dozen. Does this have an impact on the features like tool life monitoring? Now that I have 6 cutting edges on one tool, can I monitor the tool life of each cutting edge uniquely? You want it? You want me to take it?
I think you can do that. Yeah. I'm gonna pull it up.
So yeah, we can absolutely apply a cutting strategy to each of those unique cutting edges. So we can start to monitor it. Now I don't believe, and I think Dan, you're kind of showing it here. We don't have the ability of changing the strategy type between the cutting edges. So I'm either counting them quantity of parts, time and cut, or wear, but I got to do that for all the cutting
Yeah.
edges, right? That would be the one limitation there.
Yeah.
I would say the only downfall, or one of the bigger downfalls in my mind, I could envision, once you take a singular tool and a singular insert and allow it to perform as many tools, once you lose one of those cutting edges, you just lost
Yeah.
all those tools. I
Yeah.
think that's your drawback, right? So you could have, so much more life left on the other 2 cutting edges, but I lost one because that was doing my heavy turning, and effectively that insert's no good now. Where
Yeah.
if it was obviously unique tools, I could swap out that one tool and move on my merry way. But there's always going to be trade-offs, right, with any of this stuff. So you kind of got to look at the overall. But I would envision too the ability on a y-axis tool to be able to kind of lead into that cut, like you were showing, and really apply the cut load over the larger length of that insert would increase my tool life just by itself alone. So hopefully with the gain in tool life and just applying the technology properly, it's going to kind of give us some benefits.
Yeah.
Well,
I think
sorry,
that I think that to me is like you said, is having the ability to lean this tool and take such a big cut is to me is the game changer there.
yeah, no, agreed. All right. Well, I think I got everybody. I probably missed some of your questions. They were sprinkled all out. Let me just do one more quick snapshot. If I didn't, by all means, reach out to either myself or Dan. You can reach out to us through obviously the event email where you subscribe to it. And by all means, we're here as a contact to help support you. Hopefully, you guys enjoyed the event and what we were talking about. and we're going to have more in the future for sure. So we look forward to seeing you soon. Dan, thanks for coming in and doing this. I certainly appreciate it. And we'll see everybody later. Have a great weekend.
My pleasure. Thank you.
All right. Bye-bye.